Hello and welcome to this Drive Live with an Engineer. My name's Dion Knowles and I'm from Tech Equipment. And today I'm also joined by Chris Wright. While we wait for other people to join this session, I'm going to invite Chris to introduce himself.
Hello and welcome.
Chris, if you want to go forth and introduce yourself now and tell the audience a bit about yourself, factoring into account that we've got to wait for lots of people to join us at this point.
Okay. All right, sure. Well, my name is Chris Rice. I actually live in Lexington, South Carolina. And my background is I have a Bachelor of Mechanical Engineering degree from Georgia Tech. And right now I work for a company called DAK Americas, where I serve as, I guess my official title is Senior Mechanical Engineer, but I work for basically what we call our operations and our production staff. And to just kind of tell you real briefly, DAK Americas is mainly known for, we make PET plastic and also recycle PET plastic and use it into other end users. So I think we'll kind of go into a lot more depth in terms of my background and kind of how I arrived here. But what I will tell you, one thing about my role is because I'm on the production operations staff and the mechanical, my main emphasis is in the area of any mechanical equipment that we have that we need to maintain production. I mean, everything from troubleshooting equipment, monitoring equipment, making sure that it's operating properly. Also maybe even buying new capital equipment that we need, for production. So like I said, we'll get into a lot of the particulars, but I wanted to at least give you kind of a brief introduction of my background.
Brilliant, thank you. Now, what's happening right now is people are moving from the link that we sent out originally over to this link. So thank you to the many people who've made it over. We've already got 12 people who've gone from that link to this link. We're dealing with technical challenges, and that's gone up to 16. So well done, ladies and gentlemen, for moving over to there. So many of those, Chris, haven't heard that initial introduction. I'm going to do that a bit now. For those who've just joined us, this is Drive Live with an Engineer. The purpose of this series is so that students, whatever level they might be at, and anyone else who might be interested, can get insight into what different engineering roles, different engineering careers look like. What are the day-to-day activities? We live stream this on YouTube so that you can ask your questions. You can get involved. There is the chat box at the side, so please do use that chat box. Chris here is from Georgia in the USA. And Chris is going to be talking about his role as a mechanical engineer and his journey through his career from studying at Georgia Tech. And we'll be here to answer your questions. Don't forget, please to put where you're from in the chat box. I know we had Adnan and we had Nick. They both put comments in the previous chat box. Let us know, Adnan and Nick, if you've made it back over to the other side where we are here. It would be great to know where everyone else is watching from as well. So, Chris, you're in Georgia. What's the weather like with you right now?
Well, it's actually cold here this morning. I was surprised. I thought, normally when you're in the South in the United States, the winters are fairly mild, but I think this morning we dipped, down into the 30s. Well, I'm just trying to think. There's people, I'm talking about Fahrenheit. I know you have people listening from all over. I'd have to do the calculation to tell you what that is in Celsius, but if you walk outside, it's cold.
What weather is it?
Yeah, so I mean, but otherwise the sun is shining. So if you look from inside to outside, you would think it's very, very warm, but it is not.
Okay. Right, so Chris, I'm just going to pull up and show a little bit of a view of your career so we can talk about this with our audience. I'm hoping that you can see that and that everybody else can see that at this point.
Let's see.
It should be, it says it's paused. Your screen is paused. Right, this is what's so wonderful about live stuff.
You've got to love technology. It says you've started screen sharing, but it hasn't come up yet.
All right, well, let's stop it and let's start again.
Okay.
There we go. This should now be cooperating.
There we go.
There
Okay.
we go.
Yeah.
Fantastic. So, Chris, let's start off on we had a quick chat yesterday about in preparation for this, but what we didn't talk about was what inspired you to be an engineer in the first place?
Yeah, we didn't talk about that, but that's great question. When I was growing up and going to school, and this is traditionally what we get a lot here in the States, is I was very good at, all of the mathematics courses that I took. I was very good at the science courses that I took. And, when you're, kind of in, I'd say probably the latter part of middle school or beginning of high school, they start your teachers start to try and steer you in a direction to say, hey, here's kind of what we think you may have some talents in this area. And since I was so good with math and science, they said, you might be good at being an engineer. Well, what's interesting is as I had been growing up, I was the student I was the child in the house that whenever my parents needed things put together, whether it was furniture or whether it was a bicycle or anything like that, they could just pretty much kind of hand me the directions and say, hey, put this together. And so I would, and I actually enjoyed doing it. I played with Legos and would build, different things. So, you know, thinking about creating things, building things, seeing how things go together, what works together, and then also demonstrating some of that talent in math and science, they said, well, let's look at engineering. Well, the other thing I'll tell you too was when I was growing up, one of the things that was happening a good bit was the space shuttle was launching and, people going out in this cool looking spaceship flying around. And I thought it would just be so cool to one day be able to fly on the space shuttle, and so I kind of got interested in how does all this work and how do they get the rockets out there and how's the orbit work and everything like that. So everything like that just kept me on that path, pushing me towards engineering. And obviously I grew up in Georgia, and one of the best, or what I feel like is the best in the United States, one of the best engineering schools is right there, not too far from my hometown, which is Georgia Tech. So I said, well, let's start this ride and go to Georgia Tech and see where it takes us.
Brilliant. So you went to Georgia Tech and you didn't study mechanical engineering degree to start with, did you?
That is correct. What I was telling you before is I started as an aerospace engineer, just like, piggybacking on what I was saying about the space shuttle and so forth. I went into aerospace engineering, applied. It's a very challenging program to get admitted into at Georgia Tech because the demand is so high.
Yeah.
But so I got accepted into that program as a freshman and started, taking a few classes. And as I went down that path, I thought about, work experience and different things that I could do. And at that time, aerospace engineering had scaled back in the U.S.
Right.
And so NASA was starting to, lay off several people and so forth. And so what I thought was, I might need to be a little more general just in case this aerospace doesn't continue to go. So I changed my major over to mechanical engineering. So what's significant is all of the mechanical engineering students and all of the aerospace engineering students at Tech at that time were advised by the same advisor. So in a way, I left aerospace was mechanical, but I still had the same advisor to kind of say, hey, if I still want to steer this way, is there a way to kind of go back in here? I got the same advisor. So that was kind of a natural progression. But I will say this also, Dion, when I changed, I really wrestled with that decision because for a while I kind of felt almost like, did I give up on something I started with?
Yeah.
You almost have this sense of failure trying to creep up on you, just saying, hey, should I really have done that? Did I make a mistake or whatever? But looking back now, I see that, life changes and things change and you change and situations change. And so you really shouldn't look at it as if like you failed or I didn't finish this. You almost should look at it as if, okay, I branched out into something else or I found some other opportunities. And if you can keep that positive mindset moving forward, I think if you're thinking that you made all these mistakes, sometimes that really holds you back, so.
Yeah, there's certainly a merit in, thinking I've doggedly got to do something that I set out to do, I will achieve it. But,
Right.
it's if you are achieving that at a compromise of so many other things because it's wrong and stuff, doesn't mean, actually it's a bigger decision to make and it's a much stronger characteristic to go, you know what, this is not right. Let's shift things here.
Right. And at the same time, I'll say this. Nowadays, they're talking about potentially having civilians being able to get on the International Space Station. So I still haven't given up. I may still be able to achieve those space travel dreams, at some point.
Good. Well, I hope you managed to achieve your space travel dreams, Chris. So you did your mechanical engineering degree, but it wasn't a standard degree platform, was it?
Right, right. Because one of the things that was big at our school is something which we call our co-op program. Co-op is just short for cooperative educational experience. And so what that is it's cooperative because it is your education experience is an agreement between the school and also companies that partner with Georgia Tech. And so what they do is these companies say, hey, send us your mechanical, send us your chemical, your electrical, all those different engineers. They say, hey, we have certain positions that we will set up within our company around, throughout the calendar year. And so they'll come to somebody like Georgia Tech and say, hey, we have positions for 4 mechanical engineers. And what we'll do is, from one semester, maybe from January to May, we'll take those 4 students and let's just say, for instance, I was a co-op. I would work for a company just like anybody else is full-time employed from that January to May. Then when the summer semester starts up in June, I would come back to school and pick right up where I left off. Then when the fall semester starts, I would go back to that company. Maybe I might be in a different role, but it was a wonderful experience for me. Now, what it does is co-op will delay your graduation by about a year. Instead of 4 years, you may be looking at about 5 or maybe, 5.5, depending on how many co-op terms you do. But by the time I graduated, I not only had a mechanical engineering degree, I had actually worked an equivalent of 2 years as an engineer in industry. Both in the paper, I worked for Mead Paper, I was in the paper industry, and then I also worked for BP Amoco, British Petroleum Amoco. I worked in the oil and gas industry. So it really, really helped me by the time I graduated.
Now, in those jobs, you were not a fully fledged engineer, you hadn't got your full degree, you were doing work placements. What kind of work were you doing? Were you just, I don't know, I think that maybe you're just sweeping the floors or.
No. Well, I tell you what, one of the number one concerns of students when they're doing this is I'm an engineer. I want to learn engineering, but please don't put me in a back room just running copies. Many times people think it's just going to be clerical work. Well, that was not the case for me. They paired me with a mechanical engineer the first day, and he was my mentor, but he also had projects already set aside for me to do. So there were certain things that I would have to do, like basically that engineer was so busy until there would be some things where he'd say, hey, Chris, this is a viable project. It only is going to take maybe about 10 or 15 hours to do. I just don't have the 10 or 15 hours. And so he would say, hey, here's the drawings, here's the construction manager contacts, here's the engineering manager contacts. Tell them that you are the project manager and I need you to go and do, this. It's going to take 10 or 15 hours. And he says, if you have any questions, come back to me. So I really like that because it's almost like they're entrusting you to kind of go figure some things out, but it's not like they just sent you out and left you all by yourself. It was like, hey, I'm still here as your mentor. Just come back if you have any questions and we'll guide you along. I'll tell you the other thing happened to me a little bit later in my co-op career, probably a year or so later. We would do, I was in their utilities area and we were working on their power boilers, their steam turbines and everything like that. And we would do an outage once a year. And once a year, it's around the clock because you've got to get it, repaired, maintained, and back up. Well, what they would do is put me on the 12-hour night shift. So I was literally like the engineer that everybody comes to for answers from 7 p.m. to 7 a.m. And then my mentor, he was from 7 a.m. to 7 p.m. So it's pretty neat for me to keep the train on the tracks, so to speak, and then tell him, hey, here's what we did, here's the challenges we ran into, here's what needs to be addressed during the day. And that was, I think, for 12 days straight. So I was working night shift. So I didn't even realize there was a night shift in school. It's like, oh, so, this plant operates around the clock, and there are people who have to be here at times to make that happen. So I thought that was, being 19 years old, 20 years old, I thought that was pretty good being a college student, and you're in charge of this $8 million renovation that's taking place around the clock.
Wow, what a great start out. So you did your co-op degree at Georgia Tech, and then
Right.
You went to work for Solutia.
Correct.
Tell us more about that particular role. You were a project manager there, I believe.
That is correct. So originally, and I'll tell you this about this particular facility where I was shortly before it changed to Solutia. It was actually a Monsanto company. It was a Monsanto facility. And back then we were making nylon fiber was what we were making at that particular facility. Obviously, a lot of people know Monsanto now as being an agricultural company, but once upon a time, they used to have all kinds of different chemicals. So, but anyway, I was a project manager, similar to what I was telling you when I was a co-op student. It was a lot of times it's, hey, we need to put in we have certain production lines, but we want to put in a duplicate line. Or maybe we're trying to, what we call in the US, we call it debottleneck. In other words, we're trying to figure out a way we can take our existing assets and create more capacity. And so I remember one particular project I had was to take out our existing evaporator and put in a larger evaporator that had 50% more capacity. And this evaporator was sitting on top of like a 6-story building. So, I had to get involved with the cranes that we would need to pick the old one up and remove it and put the new one in, and had to work with the construction people on all of the piping that needed to be tied back into the evaporator, and work with the civil and structural engineers to make sure that the existing roof had capacity to hold this larger evaporator. So, those were some of the kind of things I did as far as project management. And it would just be everything from getting the estimates of how much it cost, working with the vendors as far as the quotes, and then working with the construction folks on, putting everything in, it's a little bit of everything. And even having to work with accounting on the back end to say, here's what we bought, this is how much it cost, here's what the assets are. So they can put them on the books and start depreciating, the cost of that installation. So, as a project manager, you just think, I'm just putting things in, or I'm just taking things out. But it's so much more than that when you look at the paperwork and the accounting and taxes and different things like that.
Was that what you expected from a career, your job in engineering? It doesn't sound, for many engineers, they think, all right, I'm going to get my hands dirty and I'm going to be crawling along pipes and stuff like that.
Right. That was not exactly what I expected. But I will tell you, the part that I liked, I thought it was going to be a little more routine than it was. But the part that I liked about project management is because since the projects change, your routine changes. What you're learning and what you're getting involved with changes also. So it's pretty exciting to me to be able to do that. And at the same time as being a project manager, I still knew in the back of my mind that experience of managing projects, managing schedules, managing budgets, all of those skills, dealing with outside contractors carries over regardless of what industry that I was going into. I even took the project manager training, took a outside training outside of my company. And it was interesting to see people from, different industries that were in there, but the methodology for executing a project was the same.
So why did you choose when you finished your degree? Why did you go for that job? Was it because actually it was there waiting for you, or?
Well, I'll tell you this, when I graduated, because I was a co-op and had all this experience, I was fortunate. I was one of the fortunate ones that having the experience that I had was very desirable in the marketplace. So I actually had, I think, 4 job offers when I came out of school. You
Wow.
know, I had an opportunity to go and work for Florida Power and Light. I would have been working on transmission lines and things like that in Florida. Then Monsanto was another offer that I had. Mead Paper, who I co-opted with, was offering me a job. And also Amoco, you know, back in Houston where I worked, was kind of like, hey, we'd like to have you too. But to be honest with you, it kind of boiled down to, I'm from Augusta. My first job with Solutia was actually in, I guess, about an hour and 15 minutes from home. And so what's interesting is my co-op experience, I had been in Houston, I had been in Ohio, I had been to all these places. But as Dorothy would say in The Wizard of Oz, there's no place like home. So even though I didn't want to come right back to Augusta and be at home, it was still close enough so that I could be independent and be on my own. But if I needed to get back and just be home and be with my parents, I could still do that.
Excellent. So then you moved on from Solutia, and then you went on to work for, remind me, where did you?
Eastman Chemical.
And why did you make that decision? Just before we do that, I just want to mention something to those that are watching us. If you're a student out there, do put a smiley face in the chat box. We're trying to get a bit of a movement going on there to see who's watching from students. If you know Rome, then, sorry, if you know Chris, I know Rome knows Chris because Rome is here today.
Hey, Rome.
Do put a comment in the chat box as well. I know we've got lots of people here with us live. Get involved in the discussion, please do. Okay, Chris, going back to Eastman now.
Yes. So this is, I will tell you this, here's another chance, just like we were talking about changing majors. Here's another thing that happened. I was working for Solutia, and Solutia was not doing all of the capital investments that they had been doing over the years. And in fact, they came through and said, hey, for us to be more profitable, they took all the people with the least amount of experience. And I was one of those people that got one of those layoff slips and severance package. And hey, we can't keep you with the company anymore. And so, thanks, but this is the end of the road for us with this relationship. So that was another time for me to almost get into, oh gosh, did I do something wrong or whatever? Basically half our department was given, severance packages saying, hey, this is it. But what I did is I just drew on the experience that I had. I basically made looking for a job my full-time job. And within, I think, 6 weeks, I had 3 more offers in hand. And so Eastman was one of those companies that offered me. It was here in South Carolina, not too far away from where I was before, but it brought me down to this Columbia, Lexington area. And, it was another role. And what was interesting is I ended up getting more vacation, more pay, more responsibilities, all of that just by changing. So in a way, I felt like there's probably a reason that this happened, because I was probably in a comfort zone, and it was a good time to move to something else. Sometimes life makes you move out of your comfort zone, but long term, I've been here ever since 2001. And so, and obviously we'll talk about the next company I'm with, DAK Americas, and DAK Americas actually bought the Eastman facility where I was working. So even though I went from Eastman to DAK, I'm still in the same location.
Wow, brilliant. Well, yeah, it's fantastic how a bad situation can be made good and turned into an opportunity. We've got lots of students. Thank you, students, for putting your smiley faces in there. Now, if you've got any questions for Chris, do put them in that chat box. So when you started at Eastman, tell us about what they're doing there, just to put it in a little bit of context, I think.
Sure. Okay. So with Eastman, Eastman is a facility that makes, at that time, they were making several different products. They made some of the products that go into making PET, but at the same time, they made the PET. And I said earlier about PET. PET stands for polyethylene terephthalate. I may not have said that exactly right, because there's like anyway, it's plastic. But at any rate, so my role changed a little bit there, because what they do is they have something they call an operations division rep. And what an operations division rep does, it's not exactly a project manager. They do some project management, but also you're kind of there to help operations with any other kind of task that they need. Like say, for instance, we have about 5 or 6 different production areas. And so being in this department, I was more of a central engineering department. And the supervisor I had at the time, he had a philosophy that said, you know what, I want to assign an engineer to a specific area rather than servicing the whole plant, even though we could, you go to this area. And it was a beautiful experience for me because now each morning I would go to the production meeting in that area and talk to them. And it wasn't always a project. Sometimes they would say, hey, our operators are complaining that this hose that they use to put into the rail cars to pull out the raw materials is a little cumbersome. Is there any kind of device we could do, or could we change this procedure so that it's, easier for them to do and less stressful? And literally, I'd have to walk out there. You have no clue what to do. I'd have to walk out there and watch the operation and ask questions, find out what their problems were and so forth, and to just literally think. What's funny is thinking is easy for everyone to do, especially engineers, but many times we refuse to think because it takes time and it takes energy. And so I'd have to just sit there and think about it and say, hey, what can we do? And I came up and I'd go online and do some research, and I found that they could put some special almost carrier arm to carry the hose and to put it where it needs to be and pull it back. And then the operator didn't have to put the hose over his shoulder. So it was a different, it was different because it wasn't like the engineers, the operation manager said, hey, go put this in. They said, hey, go look at this and try and come up with a solution. So now you're coming up with a solution. And when you come up with it, now you go into project management. So that was a pretty unique experience because it helped me think, helped me sit back instead of just rushing in, sit back and watch and think and see what kind of ideas you can come up with and see what other issues are out there in the industry or technology you can take advantage of.
Excellent. So as a day-to-day, you're out dealing with operations, and
Right.
so you specialize. There's so many different fields of mechanical engineering that you can go into. You're very much leaning on the production operations side of things in how you've progressed your career.
Right. Because we do have mechanical engineers at our site that they are more in the design aspect of things. They're sitting there and calculating the stresses and everything to say, hey, you can't use this thickness of pipe. You have to use this thickness of pipe for doing this. That was not really, and I'll tell you this, at Georgia Tech, we used to be able to kind of emphasize our mechanical engineering degree in machine design, or we could emphasize it in what we call thermal systems. So that's anything associated with, heat transfer and things like that. My degree from Tech was more in the thermal systems area.
Okay.
More so than the machine design. So that's kind of where my career went down that path. That's one of the other things I did at Eastman is I was a utilities area engineer. So I had responsibilities for all of our refrigeration equipment, our steam equipment, just, I had some of those, we would have chilled water that we would have, and I was responsible for that system. Several different things. Even we had a cooling tower that we used to cool off the process. And so I was responsible for dealing with that cooling tower. So all of those things, if you listen to them and you think about steam, you think about chill water, you think about cooling towers, all of that is taking heat from somewhere, and putting it somewhere else or cooling something or what have you. So that kind of fell in line with the thermal systems background that I had from Georgia Tech.
Right, we've got a question here. He says, hello, Chris. I was just wondering how long would a project take to finish from start to end? And also, what do you think of the aerospace industry right now regarding supply and demand?
Oh, very good question. Very good question. A typical project and depending on the company, some of them, they would call them small projects, large projects, what have you. But your typical cycle time on a project is probably going to be about a year. From conception to execution. Sometimes that can be stretched out further because it depends on, let's just use an example. Let's say we had a project that's $200,000. You know, $200,000 is what we're going to spend, but it may be the production managers and everybody who has to approve that $200,000 may take 3 months before they approve it. You may know exactly what you want to do, but then you have 3 more months added to that schedule because they haven't approved the money yet. One of the other things we run into is sometimes it requires equipment, and whether you're ordering the equipment from overseas or whether you're ordering it, within your country, things have to be manufactured. There's other engineers that have to sign off things at those companies. So sometimes we have what we call long lead items, and it might be 20 weeks before you can get the equipment. It may be six months, 8 months before you can get the equipment. But so that I would just say it depends on the size of the project. If you're doing something like you're building a whole new facility, that may be a 2-year, 3-year project. I mean, it just really depends on the nature of it. But I would just say a good cycle time on a project from conception to, final and turnover and put it in place is probably 12 months. Also, I guess the other question was about the aerospace engineering industry now. There has been a major revival in the aerospace industry. I mean, even with the International Space Station and some companies partnering on that International Space Station, I think there's a lot of opportunities now. I mean, I hate to say, hindsight is 2020, but if I was still in college now, if this was my freshman year, I was in aerospace, I probably would stay in it. To be honest, I probably would stay in it. But I think there's a lot of opportunities out there. It's just nowadays we're in a global economy. And so your position may not just be in the US. I don't know if the person asking the questions from the US may not be in the US. There may be other opportunities even with other countries, once you start to have that experience and so forth. Or, you know what, you never shy away from the fact you may be able to start your own aerospace, consultation type business. And you may have people from all over the world that may be calling for your services to help them with their program. So, I mean, I think it's a great field to be in right now.
Brilliant. And thank you to all the students out there who've been telling us what they're studying at the moment. We've got mechanical engineering, level 2 engineering students out there. Very good. Okay, so let's go back now, Chris, to your job. I'm interested, and I think the students out there, correct me if you're wrong, students, if I'm wrong, where is the boundary between the operator and you as an engineer in this particular kind of role? Okay. I mean, sometimes that boundary might be a bit blurred and grey.
Well, yes, it is. And I'll tell you what happens nowadays. Nowadays, I want to say it used to be in industry as a whole and engineering as a whole that everything was highly vertical. This is the plant manager. This is this department head. This is the area engineer. This is the operator. But what has happened is now that technology has just literally infiltrated everything that we do, some of our operators are able to look at computer trends and look at equipment and so forth and go on the internet and do research on different things and troubleshoot. And many times some of the great ideas come from the operator directly. They may come to me as an engineer and say, hey, I saw this new technology. I saw this. I've been watching this equipment. Do you think that we could do this? I mean, fill in the blank. Do you think we could implement this? They come to me as an engineer saying, because you're the engineer and you're a little more educated and you've got a little bit more background, I need you to look at it and make sure I'm not missing something. But now everything is more collaborative. So it's like what you said, the blurred line. It's almost like, yes, the operator does things and deals with things day to day, but my job is to help make his job easier. And then he does his job efficiently, which helps make my job easier. So instead of focusing on the rush and the urgency of today, by that operator being educated and working on things, it allows me to think about tomorrow and what we need to do to be in a better position. So really, it's yes, the operators work with me or work for me or follow my instructions, but it's not this thing where it's so vertical. Now it's almost a little more horizontal. We all work together as a collaborative team.
So now I'm going to skip back to the picture that we've got of your career. So okay. Eastman was bought out by DAK, or bought your site, is that right?
That is correct.
Yeah, so we kind of symbolized the different vehicles, because we've got the theme of Drive Life with an Engineer, from going from the roller coaster at Solutia to,
yes.
Is that a police car that you've got?
That is a police car. And the reason, I will just tell you, Dion, the reason I chose that police car, it's almost like shows an undercover kind of investigator. There was one project I had with Eastman where we were forming these, our plastic pellets were forming into almost like these little small rocks, probably about a 1 inch or 2 inches in length. And we had no idea where they were forming. We were finding them in the final product. And we just had to try and figure out what is going on, what is happening. So we actually were sending cameras through the pipes, investigating things. We were opening up sections of pipe. We were looking at temperatures and doing all of this. And so I was the facilitator that led this effort. And so that's why I kind of put for Eastman, as an investigator, because every time people would see me, they would almost say, we were looking for what we call them clumps. They started calling me Inspector Clump, because that's what I was doing, is I was trying to find everything out. Well, what we finally found out is that as the pellets traversed along the pipe, this particular product, those pellets would pick up energy from rubbing against the convey pipe. And as they built energy, they started to heat up. And when this particular product gets to a certain temperature, it starts to get sticky. And so they would form, there was one place in a piece of pipe where they would actually find a place where they could congregate more than others. And then they would just build on top of that. And then at some point it would get large enough it couldn't sit in that pipe anymore. It would move over to the product bin. So we ended up putting almost like chilled water coils on our pipe for a certain, where we had the most velocity, to keep the temperature of those pellets down so that they didn't clump up. And that kind of solved that problem. But it took us almost 6 months of investigating to try and figure all this out. So that's why I put the kind of the investigative police car to represent Eastman Chemical Company.
I guess your role, any engineering role, if you want to be most efficient, is you're constantly looking for new technologies, new materials, new ways of doing these things. What kind of resources and tools do you use? I'm thinking the students out there who need to keep these, maybe there's resources that they can access now, right, that they can take through their careers, maybe memberships to certain societies. What do you use?
Well, I mean, one thing that that helped me along the way was, because you do a lot of projects, you have to do estimates so that you can get money approved to accomplish those. There were a few software programs that we used to do on estimating. I wasn't solely responsible for the estimates, but as the project manager, I need to make sure the people who are estimating accurately. So a lot of times I could use certain softwares to put in, okay, I'm putting in this vessel, I'm putting this much pipe in, and it has calculators that'll calculate, okay, if you've got to put in 1,000 feet of pipe and it's stainless steel, it accounts for how many hours need to be done to weld that pipe and everything like that. And it'll spit out a number that says, hey, you're going to need, $6,000 worth of welding, $7,000 worth of welding. So, I mean, that was one thing that helped me. Now, when I got into my utilities role, some of our vendors that sell us, steam equipment will offer free training, like Spyrex Sarco, TLV, some of these people. So a lot of times I would go and take advantage of 1 day, 2 day, 3 day training. A lot of times these companies, they want to sell you their product. So they literally will, pay for your hotel. They'll pay for everything for you to come do that. But at the same time, it's not all about, obviously they tell you about their products, but they also teach you about, hey, here's how steam works. Here's how steam behaves. Here's some things you need to be aware of. Here's some things you need to watch out for. So, I mean, I would just say continuing education and training. A lot of times people are trying to sell their product to you, but ask them, hey, what training opportunities do you have? And you'll be surprised nowadays with the PowerPoints and the presentations and the web seminars and the Zoom sessions. you can get a wealth of information without having to pay a dime for it. And that would be something that would really, really be helpful for students. Right now, you got some free time, you can plug into this webinar and learn something that you can talk about in an interview intelligently. And when you're interviewing with an engineer like me, I'm going, oh, they already know about, heat transfer media. They already know about, steam flow through pipes and water hammer. They know about this. This might be somebody I need to, write down. I want to talk to them later, or we want to get a second interview with them. So that would be my advice.
Now, you've got more advice. I'm just going to mention this to everybody watching. Chris has got his top tips for you that we'll come back to at the end. So do stay with us as Chris shares those. This was not one of those. This was one thrown out there as a bit of a challenge question for you, Chris. So DAK then bought your site that you were on. Correct. And you've got a Range Rover there representing that part of your career. What's that? Why do you represent that with the Range Rover? And what were you doing in what particular role was that? I mean, I know you obviously merged over to a different company, but you will have progressed your roles, I guess.
Right. Well, that's kind of the role that I'm in now. And I picked that Range Rover SUV because guess what? An SUV is a sport utility vehicle. And the Range Rover in particular, because of the versatility of it. Some people use a Range Rover as just, hey, looks really nice. It's functional. We can drive from point A to point B. But sometimes you can drive that, because you're doing something by yourself, you're working alone. But it's got room in there so that you need to have part of your team and you're all needing to get to the same place at the same time. And then this one also has power. And when I say power, I'm not saying this as if, I have all of this authority, but I'm given a lot of leeway and a lot of freedom in my job to make decisions. I mean, to literally say, yes, we should spend $150,000 to repair this piece of equipment, or no, a new piece of equipment is $200,000. We're 3/4 of the way to a new piece of equipment. So my recommendation is instead of fixing this other one for $150, let's buy a new one for $200. So I'm given a lot of authority and a lot of latitude to tell management, here's how I think you should spend your money. And so I think about the power of a Range Rover being able to do that. The other thing is this, a Range Rover can go off-site, it can go off-road, it can stay on-road, it's got the 4-wheel drive, it can handle snow and that type thing. And honestly, sometimes I may have to be talking to our plant president about what we're doing. But then I may have to go and talk to an operator that just graduated from high school, knows very little about our process, and I need to explain to him what we do. So I'm not going to say which one is on-road or off-road. I leave that to your imagination. But the fact of the matter is, you need to be able to be a diverse vehicle in the role that I'm in now to respond to whatever requests come that day. And you may have to, for lack of better words, you may have to talk with kings on one day, and then you may just have to talk to the person on the street the next day. But you have to learn how to deal with all of them equally and to treat them all fairly. And, because that's just my philosophy in life, is that everybody's role is important, no matter where they are, no matter where they are on the organization chart. And so to me, a Range Rover, irrespective of what surface you put underneath it, it still does what it's supposed to do.
Great. We've got another question now from Robbie Isles. Robbie, thanks for your question. Okay. He asks, as an engineer, how would you describe your day in the life? Do you enjoy what you do? And are you happy with your decision of becoming an engineer?
Very good question, Rob.
Lots of questions in there, in fact.
Yes, very good question. So let's take the first one. So daily life. My daily life really is, the first thing we do in the morning is we have a morning call. Now, pre-COVID, we would actually all sit in the conference room. And we all kind of go around and say, hey, here's my high nails for today, or if there's some special problem in production, who's going to work on it? What's the priority or whatever. Nowadays, since we're in these COVID times, pandemic times, we do it all via Microsoft Teams. So we just get on there and talk through. We do the same thing. It's just we're not face to face. But then the next thing that I do is I have equipment in my area, and I've gone and built charts that monitors, we have computer monitors and things to tell us whether we're in an alarm state or what is our vibration and all this type of stuff. I open up my trends and I look at them. And because I look at them every day, I pretty much know what they're supposed to look like when everything's operating properly. So I start looking for any anomalies in my trends. If I see any anomalies, then guess what? I'm going out to the production area to look to see, do I hear anything? Do I see anything out of the ordinary? Or I'm talking to operators or team managers and say, hey, did something happen last night? Were we doing something special on the line? So that's kind of some of the day-to-day. There's meetings that you have that come up periodically. A lot of times, it's just, you can email back and forth, but sometimes it's easier, instead of waiting on a chain of emails, to let's have a meeting, let's have 4 of us sit together, let's hash things out and, decide what our path forward is. Then the other thing might be, if I'm working on projects or if I have construction working on projects, I go to see how's it going. Are they running into any roadblocks? Is there anything I can do? Sometimes they need more information. I may have to go back and research drawings or research historical information, or may have to try and track down who's the vendor, talk to the vendor rep and, get this information. So those are just kind of some of the day-to-day things, and it changes from day to day, but that kind of gives you an idea of the daily thing. But, I'm happy with my decision. What's been quite interesting is being in the engineering field and with technology doing what it's doing, I have found that my employment has been stable. The income, every single one of us, we always want to make more income. I mean, you just ask me, oh yeah, I'd love to make more money. But, I have been able to provide a good living for my family. We've been able to go do certain things, even as part of my company. I've actually been sent to China to look at some equipment or that we were looking at purchasing, so guess what? No cost out of my pocket. But I spend 7 days in China, seeing Beijing and seeing some of these different places. I've been to several different places just for training and different things like that. So engineering's opened up a whole new world. So, I'm happy with it. But like I'll kind of tell you in a second what some of my takeaway points. But at the same time, I'm always just looking to see, what other doors of opportunity open up. Now, just because a door of opportunity opens up doesn't mean you have to walk through it. But, it's great to be in a room and have 4 doors that you can choose from versus being in a room and there's no doors. You can't get out. So I've been happy. I hope that answers your question.
Brilliant. Thank you for that. Thanks, Robbie, for your question. Anyone else on any questions, and do put them out there. Now, earlier, we touched on the co-op thing and the benefits of, I know I did my degree, a business degree, and I did a year out in industry, and I personally can talk about the benefits of that in terms of being able to go out and get a job because you've got experience already on your CV.
Right.
And for you, but yesterday we had a chat about this, and you talked about it also helping you focus.
Yes.
Being able to be fresh and going into, having time off in industry and then coming back to your studies. Do you want to talk a little bit more about that?
Sure. So as a co-op, and maybe I didn't go through this before, but in a cooperative education program, as a co-op, you basically go to school for 1 semester, and then you go and work in your field in industry for a semester, then you come back to school and you go back. So you just keep alternating until basically you progress through your classes and it's time for graduation. Well, some of the advantages of that for me personally were, as we alternated, I found that I was fresher every single semester when I came back to school. Because I don't know if there's college students that are out there listening. Once you start in August in school and you work really, really hard and you get to December and it's maybe, the holidays, and you take a couple weeks off and then you come back in January and you start again. By the time you start getting to February, March, sometimes you're burned out. You're just like, oh, when is this semester going to be over? Well, for me, because all I had to do was short burst of time, 1 semester. Let's do all I can to get all of my studies done. And then all of a sudden I'm leaving for 4 or 5 months to work in industry. I'm making some money, and I'm learning about my field. When I come back to school, it's like I've been off for an extended summer. So now let's just focus on school. So it helped me because my mind was fresh and I just knew this was for a short period of time. And then boom, I was going to be going back to work. And I found my grades literally improved from before I started. I started my co-op program my sophomore year. So my freshman year, I went straight through. But I mean, my grades went from, I think I ended up having almost like a 2.6, like that last semester of my freshman year. Started co-op in that summer, came back that fall. I think I made a 3.7. And then it's like a 3.8. And from then on, I mean, my grades were always in 3 point something because I was always fresh, 3.3 or 3.5 or whatever. So, I mean, it really helped me there. The other thing that it helps with co-op does is it helps you to figure out what you want to do. But listen to this, students, it also helps you figure out what you do not want to do. See, because sometimes you may have an experience and you might be, and I'm not picking on research and development, but you might be in research and development and you find out you hate it. Well, I won't say you hate it. So you really dislike it. So now when you're coming out for school, don't go interview for research and development positions because you already co-op for 4 months in that and you realize that's not something that you really want to do. So it helps you to know that. But then it might be something like you worked in utilities or you worked in sales and marketing or whatever it is. And you say, I really want to be in technical marketing. And so now when you're looking for career positions, you do that. You look for that. The other thing I noticed also about co-op is now my perspective was different because when I was at work, now I understood what that heat transfer class was trying to teach me in terms of why is this heat transfer important when I'm working in a building where I'm putting steam on a process line and I've got to get enough heat transfer to keep that process from literally setting up or getting too hot where it melts, in the pipe. And then at the same time, I would be introduced to some concepts of working. And when I would go back to school and I'm taking fluid mechanics, I was just calculating fluid flow at my job. So now when I'm talking to the professor, I'm right on where he's taking us before he even takes us there. So there was a lot of advantages there. And I think I even spoke to earlier about, obviously it's a competitive advantage because when you're graduating and you're starting the interview and they say, tell me about a project you worked on or tell me about a class that you had. Now I could sit there and say, hey, I took heat transfer. And by the way, we did a boiler outage and we were doing this. And the reason we had to do it is because scale had built up on the pipes and the scale on the pipes restricts the heat transfer. So we had to go and put new tubes in and I can talk through that. And an engineer sitting across the table, or HR manager sitting across the table says, we got that exact same problem. We need to hire that lady. We need to hire that guy. We need to bring them in because they already have experience at what we're doing. And then on top of that, I guess the last thing I would say is as a co-op, they actually pay you for all this experience. So you can use that money to pay for books or pay for housing or whatever when you're back in school. And in fact, a couple of the co-ops that I had, they had scholarship programs where they literally would pay for my books. Just as part of being part of their program, they say, we're going to pay for your books. So in those cases, the money I'd set aside for books, I was able to just keep in the bank. And I'll tell you, there's nothing like being a broke college student. I mean, you college students, listen, no, it's not like being a broke college student eating ramen noodles and then turning around and being able to actually have money to go buy a chicken sandwich or a salad or whatever. And it's not taken away from anything else. It's extra that you got while you were co-op. So that's probably more than what you wanted to know, but that's why I talk about the advantages.
I think that also applies to getting a part-time job as well. Because you might not be. We've got engineering students on here that are probably not necessarily on a co-op or sandwich degree or whatever, but you can get that same experience by working on a Saturday somewhere, or the days you're not working or whatever. But I have some questions, Chris.
Yes. Okay. Sure.
Our students here. A has come back with another question. What kind of tests and applications would you have to do when dealing with aerodynamics on a car? Maybe they're working on a project and they'd like some help. I don't know. But have you got any thoughts on that one? So
You're saying, say the question one more time, Dion.
what kind of tests and applications would you have to do when dealing with aerodynamics on a car? Well, I can answer one thing. I think if you look at the tech equipment website and you look under our aerodynamics section, you probably see lots of different tests in there that you might want to consider and that you'd want to look at. But Chris, maybe you've got some things.
Well, I mean, when you start dealing with aerodynamics, I mean, one of the things also is obviously simple things like friction, friction and drag and so forth. I mean, it depends on if you're working on a project. One of the things you may do, I remember when I was in school, we used to have to do some things with cars, and we would use different canisters, different size canisters, carbon dioxide canisters. And depending on the size that we would put into the car, we would time how long it takes for that car to travel from, point A to point B. And then we would even change the surfaces. We would change surfaces. One would be a rough, almost sandpaper surface. Another one would be like a smooth racetrack. Another one might be something in between. And so you could use sometimes the timing of how long it takes to travel on a surface to do certain things. From an aerodynamics perspective, you also could get maybe a fan, maybe a fan that you could direct, not a large box fan, but like a small fan. And if it's adjustable where you could control the airflow, then what you could do is maybe direct that along the track. And as that car comes down, see how does the different velocity flows coming at it affect how fast that car can get from point A to point B. So, I mean, I know exactly what you're working on, but those are some of the practical things I could see I would do to test things aerodynamically. And probably my data point I'm looking at is how does this time change based on the surface, because the constant is going to be point A to point B is going to be the same distance. So now I start changing other different things to see aerodynamically what's changing. I mean, you could even do it with the car. You could even add things, paper clips, things like that onto the car to see, oh, I created more drag, or I made this, instead of a smooth shape, it's now a box shape or whatever, I mean, I feel like I'm back in college now, the way we're talking through this. I hope that answers your question. Those are just my thoughts.
Excellent. Thank you, Chris. Anyone else watching have any thoughts on that, then please put your answer to A in the chat box. Adam's also got a question. And Adam asks, how did you get to where you are today? Are there I think if Adam's joined us late, he probably wants to watch through this again and we can find out about the journey. But do you think there's certain characteristics, maybe certain individuals, role models perhaps, that have helped you get to where you are today?
Well, I will say this, probably, I mean, you can go into a lot of detail, but to try and keep it as simple as possible, I think the biggest thing that has helped me get to where I am today is always having a willingness to learn.
Mm-hmm.
Just like I mentioned, when I was a co-op, I had a mentor. He said, go and try this and come back and ask me questions or whatever. Well, I was always willing to learn. I never got to a point, even now as an engineer and working now, I've never gotten to a point where I'm like, I know it all. I know it all. I'm the guru. I know more than anybody else. I can't learn from anybody else. I would say first thing is having the willingness to learn has been one thing that's helped me get to where I am. The second thing that has helped me is learning how to do three things: to try, to fail, and to adjust. Try something, just like what my first job, as a co-op. Hey, go and try this and then come back to me with any questions. I tried this. Ooh, that didn't work very well. I failed. Come back and say, oh, and the engineer or the mentor, whoever says, oh yeah, that's no problem. Failure is not a problem. Failure is not a person. Failure is an event. He say, listen, you failed. Adjust and change this way and go back and do this. And that's what I've done through my whole career, is just try, fail, and adjust, and just always been open to learn.
Brilliant. Were there any inspirational individuals in your life? Were there any particular lecturers or TV stars or, people, iconic people that you thought, oh yeah, that's really inspired me to do that? Or
yeah, well, I'll tell you this. My first inspiration was actually my mom and dad. Both my mom and dad were school teachers and school administrators. And they had told me, they said, listen, there is nothing that you can't accomplish if you set your mind to it to accomplish, and they told me, they said, education is like the key for you, just opening up a world of opportunities. So, I mean, that was my first inspiration, is that they were always positive, always encouraging me, always telling me, hey, get educated, learn what you can, it's going to open up opportunities. And they always believed in me. So that was probably my first inspiration. One of my other inspirations, I go back to my aerospace, was when I saw Ron McNair. Ron McNair was one of I believe he was the first, African-American male to actually be on the space shuttle. Now, unfortunately, that space shuttle, that was the launch that they did when the space shuttle actually exploded, back in, I think that was in the late 80s or whatever. But just seeing, guys like him accomplish what they were able to accomplish, and see that there was a world of opportunities, and they were going to allow, it was a level playing field to allow anybody, regardless of their background, to be able to participate in this program. Those were some of the things that inspired me too, because in aerospace engineering, to be honest with you, at Georgia Tech as a whole, there's not very many African-American students at the school to start with, much less in aerospace engineering. And so those were just some kind of motivational things that says, hey, if he can do it, I can do it. So that's what I would say, probably in the home first, and then just kind of seeing some of these people succeeding in the aerospace industry.
Excellent. I hope, Adam, that's helped answer your question. And if it hasn't, then please do come back to us and we can clarify further. Now, I think this would be probably a good time to talk about your takeaways.
Okay, sure.
Top tips. So if I'm going to share my screen, screen, let's get that to cooperate with me now.
Hopefully it cooperates with you.
Hopefully it cooperates. Here we go. It's this is your mechanical engine, your little meme that we're talking about. Let's cover that one off for a bit of a laugh quickly.
Let's see. It hadn't come up just yet.
Let me see.
I may have to try it again.
Oh, I need to try it again. Yes, it's
okay.
Temperamental today.
While you're pulling it up, I mean, I can tell them. I laugh because many times people ask, what do engineers do? Even my daughter sent me an Instagram post the other day where she said, hey, I still don't know what engineers do. People just want to know, what do engineers do? And then there was another guy that commented on the Instagram post that he said, my dad's an engineer. I still don't know what he does. He goes to work and then he comes home, and that's about all that I know. So, but at any rate, I thought about this meme before, and I shared it with Dion from memory. He talks about, if you look at the mechanical engineer, what my friends think I do. When they hear mechanical engineer, many times they think a mechanic, like an auto mechanic. So the friends think, oh, he's an auto mechanic. And then in terms of what my mom thinks I do, I flash back to what I said earlier about my parents would say, hey, I need somebody to put this together. So they think a mechanical engineer grabs wrenches and does this. It's so funny. I'll tell my mom I got off work late, and she'll just be like thinking, well, I guess he was building something, or he didn't want to stop turning the screws too early or something, But then what society thinks that we do is they think that it's all about, I'm wearing a suit, I've got on a hard hat, I have some drawings or some prints, and then I'm constantly just, pointing, point at this, point at that, look like we're busy. And then what the government thinks we do is that, you can just tell the engineers to design something, and then 2 weeks from now, they've got it, just whatever, put it all together. But what's funny is I thought about, from mechanical engineering perspective, what I think I do is I'm capable of building the Iron Man suit. There is no Iron Man without the engineers designing the suit. But really what we really do, and I thought this was pretty funny, is you do spend a lot of time in front of the computer, especially these COVID days on Zoom and all of this, because we're not face to face all the time. But honestly, everything that you see there, mechanical engineering in my mind represents a little bit of everything you see on the screen to a certain degree. Sometimes you may be working on a project that is just, it's going to change the world. It's just great. Other times you may be designing something individually, like an Iron Man suit. But at times it gets down to the basics of, you have drawings and you're explaining things to people. And sometimes literally I may be out there with an operator and we need to adjust something on the machine, and he needs a helper. And I literally put my gloves on and I help hold something while he turns the wrench. So, so that's kind of it for mechanical engineering. But I thought that you get a kick out of that meme.
I rather like that. So go for it then, Chris. Tell us your top helpful hints.
Yeah, so these are my takeaways. I mean, some of you may be in industry already, some of you may be college students, but the first thing that I say is that what you should do is you should make sure, I think I've already said this before, but make sure you learn to get along well with others. I mean, you get along well with others. And the reason I say that is because no matter what industry you're working in, we're in such a diverse world. There's going to be people from different backgrounds. You'll be working with people much older than you. At some point, you'll be working with people much younger than you. You'll be working with people of different genders. Now we're starting to see a lot more female engineers come into industry. And you know what? We treat them equally just as any of the male engineers. You have people from different cultural backgrounds, different races, just different beliefs. Nowadays, we're in a global economy, even different countries. Like my supervisor right now that I have is from the UK, so it's just, you never know what you're going to experience. And I thought about, everything that's being done nowadays in every industry is collaborative. We work together as teams, we work together in groups. We're all partnering to accomplish a common goal, which reminded me of an old African proverb I heard years ago. It said, if you want to go fast, go alone. But if you want to go far, go together. So that's what I would say. Just keep that in mind. The second takeaway I have is really just look for opportunities all the time to grow professionally and to grow personally. Professionally would be if there's training related to your job or your profession, take advantage of that if you can. If there's special projects or special teams you can participate in within your company, take advantage of that. If there's other job opportunities, maybe there's a job position over here, you fit those qualifications, but it's not exactly what you've been doing. Hey, apply for it, because there may be some opportunities. You may find something you even love more than what you're doing now. You may be exposed to people you wouldn't be exposed to that might open up other opportunities. At the same time, there may be job opportunities at another facility within your company. You may have to relocate. Don't be afraid of that. Keep an open mind about growing professionally that way. Also, there may be opportunities long-term outside the company. You may end up becoming the foremost authority in some particular area, and you might have, who knows, maybe Elon Musk from Tesla calls you and says, hey, I want to hire you and I want to quadruple your salary. So just always be open to that. As far as growing personally, read and study good books. There's lots of books on communication. Communication is so vital. Even though engineers, we like to do our calculations and kind of get alone and do stuff. Nowadays, you've got to be able to communicate your ideas to get those ideas funded. You communicate your ideas for people to realize you're ready to be promoted to that next level. So read and study good books on communication, or even books in your field, or things that are available there, technical manuals. And then don't be afraid to stretch yourself out of your comfort zone. Do something maybe you haven't done. Maybe you want to learn how to play the piano. It's not too late. Start to do that. Many times that starts to cause the creative juices in your brain to flow. And you'll be surprised how opening up the creative side of your mind sometimes can help you on the technical side of things you're doing at work. And then the third thing, my third takeaway is always, 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 if you can, take time to share your experiences with others. There's other students that are behind you. For those of you who are still students in college now, there's freshmen that are not where you are. Share your experience. Hey, here's what I learned. You know what? You might have failed a class. You might have had to take a class over again. You might have had to drop a class. But you know what? I still graduated. I still accomplished what I wanted to accomplish. I still was able to get a job. Same thing with the new students. Some of you who may be listening, you may be in industry now. Take time to talk to those people who are less experienced than you in that role and share with them your experiences. Because the more you help others, you'll find out, if you help other people get what they want, it's almost like life has a way of coming back and helping you get what you want. So take that time to pour back. I do a lot of volunteering in our Lexington One schools. Obviously pre-COVID, but I go in and I talk to the kids about, hey, here's the different engineering roles. I talk to them about, hey, here's what I do in PET. Here's the classes you need. So those are my takeaways. My real takeaways are learn to work well with others, look for opportunities to grow professionally and personally, and take your time to share your experience with others.
Brilliant. We have another question, Chris.
Okay.
What was your studying routine like when you were at university, college?
Yes, very good question. Excellent question. So here was how I worked. I like to go ahead and get things done and out of the way. So I set my schedule up so that I took all of my classes in the morning. I know a lot of college students don't like 8 o'clock classes, but when I could, I set my schedule up so that I had an 8 o'clock, a 9 o'clock, and a 10 o'clock, or maybe like an 8, 9, 10. I basically set my schedule up, except for probably labs. I set them up so that my classes were in the morning. So by noon, I was done with class. Then what I would do is, this is kind of funny. What I would do is I'd go find a quiet spot. Well, here's the thing. 12 o'clock, I would go to our student center, hang out with my buddies for an hour, hour and a half, 2 hours, from probably 12 to 2. And most of them liked afternoon classes. So then they would leave and go to class. Well, about 2 o'clock, I'd go to the library, find one of those nice little cubicles in the quiet section, and take a nap. I literally would. I'd take probably a 30-minute nap or 45-minute nap, and then I would start studying. And so, but it was almost preparing me for working, because I'd start studying probably 3 o'clock, and then I may study for 2 or 3 hours till about 6 o'clock, till all my buddies got out of their class and were ready to go eat dinner. Then we go hang out, eat dinner. Then I go back to the library and study a little more. I may go to the student center and, play basketball or work out or whatever. But that was kind of my routine. And so it was classes in the morning, hang out with the buddies during the day, and then study in the afternoon, hang out some more, and then study some more at night, or go to a basketball game, football game, whatever. So that was kind of my routine. I hope that helps.
Excellent. Good. I like the addition of the nap in there. Finding the
Yes.
quiet corner in the library and going for a nap. There's a lot of merit in that.
Yeah, I wish as a professional that they would implement naps also. I think that would be really helpful. But I hate to bust the bubble for a lot of the college students. But once you start working professionally, the naps go away. You have to go home and take your nap.
Yeah. What about homeworking? You could get a nap in there, maybe.
Yeah, you could probably do that. You could do that before you get a nap and then get your homework done.
Excellent. Good. Brilliant. Well, it's been a great pleasure to talk to you today, Chris.
Thank you, Dion.
It's been wonderful to have so many students join us today as well. Get involved, ask your questions. I do want to remind you that we have these regularly. We have a playlist on the Tech Equipment YouTube channel just for all the Drive Live with the Engineer series. We've got different engineers, whether they may be other mechanical engineers, chemical engineers, petrochemical engineers, all different disciplines across different industries as well. Do check those out. You can post questions on those as well. Look out for our next one that's coming up in March. And that is on the playlist, ready for you to subscribe to. Now, we sometimes encounter difficulties like we have today on Zoom. So it might be just worth you subscribing to the Tech Equipment YouTube channel, because then you'll get notified when we're going live anyway. So that will kind of give you that safety blanket so that you don't miss the live stream that you want to see. Thank you, Chris. Great.
Thank you, Dion. It's been a pleasure. Been a pleasure. Thank you for having me.
And oh, hold on, we've got another question. It's
Okay.
not over yet.
Sure.
When will you be live next time? Oh, that's a question for me.
That's for you. Okay.
Okay. Let me look at my schedule a second. I believe we are live on the 3rd of March, but that is my memory, and my memory isn't always the most amazing. So let me have a quick look at the playlist.
Well, Dion, while you do that, let me just say this thing. I mean, you all have heard me talking so much about mechanical engineering. That's my journey. But remember, keep in mind, there's many other engineering paths to follow. You've got your mechanical, like I mentioned, but there's also electrical, chemical, civil, industrial. One of the hot ones now is, biomedical, nuclear, aerospace. It's just, there's a world of opportunities in engineering. And so I just encourage more and more people to go into that field. you know, because I mean, it's everywhere everywhere you look, everything you're involved with, everything that we use, all of the devices, engineering's involved with that in some capacity.
Really good point. Now, my memory did turn out to be good on this occasion. It is the 3rd of March, and we are joined by Patrick Mattis. Patrick is a mechanical, he started out doing mechanical engineering, but he's actually moved more into software engineering. He's done a lot of work on robotics. So do join us on the 3rd of March. It's a Wednesday at 2 p.m. GMT. So if you're in the UK, it's 2 p.m. If you're in Georgia, then it's going to be 9 o'clock in the morning for you. Do subscribe to that playlist. Check out those videos. Check out the previous ones. The link is in the chat box for you now. Fantastic. Thank you so much, Chris. It's been a great pleasure. I hope you have a great day, and I'll catch up again another time.
Sounds good. Thank you for having me again.